Hello and welcome back. I want to start this video with a little bit of an explanation for where derivatives of logarithms come from. And essentially, as long as we know how to take the derivative of an exponential, we can take the derivative of a logarithm. So first of all, we have to remember the following fact, that that logarithms and exponentials are inverses of one another. So if I take the log base a of a to the x, this is just equal to x. If I take the log base a of a to the x, the exponential on the inside and the logarithm on the outside essentially cancel out. Likewise, this works in reverse. If I take a raised to the log base a of x, this is also x. And here, this is what I will use to find the derivative of a logarithm. So let's take the derivative of a to the log base a of x. Well, firstly, if I use my identity here, this is just the derivative of x, and the derivative of x is just 1. But another way to look at this, if I take the derivative of a raised to a power, well, I can use my chain rule. This is going to be a times, it's going to be a raised to the log base a of x times the natural log of a times the derivative of log base a of x. The part in front, this is just the derivative of a to the x, but with a log base a of x stuck in top. The second part is going to be the derivative of the inside function. So again, we have the outside function, and we've taken its derivative, and then we have the derivative of the inside function. So we know that all of this is in fact just equal to 1. And I can solve for the derivative of the log base a of x. So the derivative of log base a of x is going to be 1 divided by this guy, a to the log base a of x times the natural log of a, and this guy is just x. So to summarize, I can take the derivative of logarithm by just taking the derivative of an exponential and using the chain rule. So we can see that this sort of makes sense as long as we believe that the derivative of an exponential is what it is what we've said it has been. Now, natural logs are also going to be pretty easy. So a natural log, when we have the natural log of a variable, this is just going to be log base e of x. So when we're working with base e, just like with exponentials, some special things happen. So if I take the derivative of the natural log of x, this is going to be 1 over x times the natural log of e. But the natural log of e, well, log base e of e, that's just 1. So we just get 1 over x. So this is a very handy, so let me write this down just by itself. The derivative of the natural log of x is 1 over x. So this is a very, very nice identity to have. So let's do the following. Let's take the second derivative of x natural log x. Well, in order to take the second derivative, we need to take the first derivative. So let's take the derivative of x natural log x. We have ourselves a product rule here. So I'm going to take the first times the derivative of the second plus the second times the derivative of the first. So again, we just take both functions and we multiply it by the derivative of the other one. So to simplify here, so x times the derivative of natural log of x, well, the derivative of natural log of x, like we just said, is 1 over x. And the second one, we've got the natural log of x times the derivative of x, and the derivative of x is just 1. So this simplifies down pretty nicely. X divided by x, or x over x, well, that's just 1, and the natural log of x, that's just going to be natural log of x, because if we multiply anything by 1, it's just 1. So this is a pretty easy derivative right there, because then for the second derivative of this guy, second derivative of x natural log of x, well, that's just going to be the derivative of this guy. The derivative of 1 is 0, and the derivative of natural log of x is 1 over x. So this is just 1 over x. And it may seem kind of silly, but it all just kind of works out. It's quite nice. Let's do. I gave myself some more space. I thought it would take more space, but that was a pretty quick one. Let's take the derivative of the natural log of 3x. So again, what we can see is we have ourselves an outside function and a function that we've plugged into it. So we have natural log of x, but we've taken 3x and we've plugged it in. So if I take the derivative of the outside, so the derivative of the natural log is going to be 1 over what's inside. And we're going to take this times the derivative of the inside. But the derivative of 3x is just 3, so I get 1 over 3x times 3. The 3's cancel, and we get 1 over x. Now, again, just like before, when I look at a natural log, there's special rules for this. And in fact, the natural log of 3x is the same thing as the natural log of 3 plus the natural log of x, right? If you add logarithms, we multiply their insides. So what is the derivative of the natural log of 3x? Well, this is the derivative of the natural log of 3 plus the natural log of x. Natural log of 3, this is just a number. I've plugged a number into a function, I get a number. And since it's constant, that's just a number, the derivative is 0. It doesn't change. The derivative of natural log of x, though, we just learned that that's 1 over x. So this whole thing is 1 over x. And we get the same thing both ways. So up here, we applied the chain rule. Down here, we used one of our rules of logarithms. Both absolutely work. This last one, I want to look at the derivative of the natural log of x squared. So, and in fact, I want to look at the second derivative of this guy. So, to take the second derivative, let's just take the first derivative and then take one more derivative. So what's the derivative of the natural log of x squared? Well, here we have an outside function and an inside function. Our outside function is when we square it, and the inside function is just going to be the natural log of x. So what I'll do is I'll bring down the power, and I'll raise it to the one fewer power. So 1 less than 2 is 1. And I need to take it times the derivative of the inside. Well, the derivative of the natural log of x is just 1 over x. It's going to be 2 times the natural log of x times 1 over x. So this is going to be 2 times the natural log of x divided by x. And that's it. Okay? So that is the first derivative, but we want the second derivative. So the second derivative of the natural log of x squared, well, we just need to take the derivative of our derivative. And here we have a quotient rule. So let's start applying the quotient rule. I need to take the bottom and square it. I need to take the bottom times the derivative of the top minus the top times the derivative of the bottom. So here, I've got x times the derivative of 2 times the natural log of x. Well, if I'm taking a function times 2, when I take the derivative, I can just pull that out. And the derivative of the natural log of x is 1 over x minus 2 natural log of x. Well, the derivative of x is just 1. And that's all there is there. So as we start simplifying, x times 2 times 1 over x, well, the 1 over x and the x cancel, so I'm just left with 2, minus 2 times the natural log of x times 1. Well, anything times 1 is just itself. So if I pull out of 2, I can say this is going to be 2 times 1 minus the natural log of x over x squared. And I think that's about as simple as I can make that fraction. So logarithms, and in particular natural logarithms, are very easy to take the derivative of. When we have logs that aren't base e, we get these little extra factors showing up in places, but that's about it. When I'm taking the derivative of a natural log, we end up just having to use the chain rule a bit, but the derivative of natural log is 1 over x, which is a fairly simple function to work.